Welcome to your favorite channel, Maths Bay channel. This is your tutor, Mr. Nhlakani Pongwane. Okay, so this is the problem we are dealing with today. As you can see, we are requested to find the general solution of this problem, and our variable really is theta there. So this is a very interesting problem because when you look at it, when you take a first glance at it, it looks as though it's one of it looks as though it's very complicated, right? So it may scare you a bit, and examiners like to do these things. They like throwing problems that are unusual at times. Okay, so you need to relax and take a careful look at your problem and see what is it that you are used to, what is it that is familiar, what is the structure, and what is the pattern, right? The first thing that you can see is that you have a sine theta on your first term, right? And you have a sine theta on your second term, and then you don't have any sine theta, or you don't have any theta variation on the third term, right? So the problem reads 3 to the power 2 sine theta minus 10 times 3 to the power sine theta plus 9 equals to 0. Okay, so as I've indicated, you have the first term and the second term constitute a sine theta, and then the last term is just your constant. But another thing that you have to try and establish before you solve this problem is to check what is the main difference between the first term and the second term. And you can see that the difference really is the fact that besides the coefficient, the coefficient on the first term is 1 times 3 to the power 2 sine theta, whereas the coefficient on the second term is 10, right? The main difference is that on your exponents, on the first term you have 2 sine theta, on your second term you just have sine theta, and then on the third term you have 0 times sine theta. So there's sort of a pattern that you can establish here. Okay, so if you look carefully on this, you will see that 3 to the exponent sine theta is common on both the first term and the second term. Therefore, if we can sort of try and make this equation look normal, look something like something we've seen before, and sort of associate a variable to 3 to the exponent sine theta, you will see that we will have a variable on the first term that will also appear on the second term, and then this problem will look like something very familiar, something that we've dealt with a number of times. So if we say let 3 to the power sine of theta equals x, right? So wherever we see 3 to the exponent sine theta, we have an x. We put an x there. You will see that our problem becomes, so this part 3 to the power sine theta is x. So our problem becomes x, then you have an exponent 2, because 3 to the power sine theta is x, and then you are left with an exponent 2. Then you have minus 10, and then 3 to the power sine theta is x, then you have plus 9. So this is where the gist of this problem lies. It's in seeing that this is actually a quadratic equation. All you have to change is this 3 to the power sine theta and make it look like something you are used to, right? So now we have x squared minus 10x plus 9 equals 0. So this is something that we can easily factorize because we have dealt with these types of equations since grade 10, I think. So if we open our brackets like this, and say equals to 0. So we know that since we have x squared, that means the factors of x squared is x and x, right? Because x times x gives you x squared. And then we look at the sign in our third term. The sign is positive, so that means our signs in the middle will be the same, because whether you have negative times negatives, it will give you a positive sign, and whether you have a positive times positive, it will give you a positive sign that you have there. But what determines whether the signs in the middle in these factors will be negative or positive is the middle term. So since it's negative, we know that we will have negative here and negative here, right? So now we are asking ourselves an important question. What are the factors of 9 that when added will give you an answer 10, right? Because since our signs in the middle are the same, that means on your middle term you will actually add, right? So our factors, if we take a chance at 3 and 3, we see that that won't work, because even though 3 times 3 gives us 9, but minus 3 won't give us minus 10. It will actually give us minus 6. So another set of numbers that will give us minus 10 when we add them, it's minus 9 and minus 1. So we can say x minus 1 here, and then x minus 9 here. Okay, so if you look at this, you will see when you are multiplying, when you're trying to get back to your quadratic equation, x times x is x squared. X times negative 9 is negative 9x. Negative 1 times x is negative x. Then negative times negative positive. 1 times 1 times 9 is 9. So then the negative 9x minus x will actually give you negative 10x. So this means we have, as part of our solutions, we have an x minus 1 equals to 0, or x minus 9 equals to 0, right? That's because we are multiplying there. So that means x is equals to, we take the minus 1 to the other side, is equals to 1, or x is equals to 9, right? And then we recall that x is equals to 3 to the sine theta. You can actually say that. You can say, but x is equals to 3 to the power sine of theta, right? Okay, so that means we can now, on these x variables that we have here, we can substitute with 3 to the power sine theta. Okay, so we have 3 to the power sine theta is equals to 1, and then or we have a 3 to the power sine theta equals to 9, right? Okay, so you can even check this. So if you put 1 where there's a 3 to the power sine theta, you have 1 squared minus 10 times 3, 10 times 1 plus 9. So we have 1 minus 10, that's minus 9, plus 9, that gives us 0. So this is valid. And even if you can put a where there is 3 to the power sine theta, if you can put 9, you will see that this is actually true, because you have 9 squared, which is 81, minus 10 times 9, which is 90. So 90 minus 81, you have a minus 9. So minus 9 plus 9 is equal to 0. So this is very true. Okay, so now you are dealing with with exponents, right? So when you have a situation like this, you have to try and write this side in terms of the base that you have on the left hand side. So how we do that is we say 3 to the power sine of theta is equals to, we know that since we have 1 here, it's very simple. Any number to the exponent 0 is equals to 1. So we can just say 3 to the exponent 0. So we have the same basis on the left hand side and on the right hand side. So this basically boils down to the fact that sine theta is equals to 0, right? Sine theta is equals to 0. So we will try and deal with this, right, in a moment. So if we come back to this one, 3 to the exponent sine theta is equals to 9. So you have to do the same thing. You have to write the right hand side such that it has the same base as the left hand side. So we have 3 to the exponent sine of theta is equals to 3 to the exponent 2. You know that 3 to the exponent 2 is 9, right? Because 3 squared is 9. So this means on this side we have a sine theta is equals to 2, right? Okay, so if we look at let's first deal with this one, with this side. If we look at sine theta is equals to 2, okay, so even though this solution, if you put a 9 there, it worked, but the fact that you have sine theta equals to 2, so this means that the answer here is undefined, because sine as a trig ratio, if you have on your coefficient, if you have 1, it means the boundaries are positive 1 and negative 1. So that means your amplitude is 1 and your trough is negative 1. So you cannot have anything more than 1, right? So you cannot have a 1.1 when you put a value there at sine theta. So that means we have an error there. That means we're going to proceed with this sine theta equals to 0, right? And I will sort of explain this side more when we are dealing with this sine theta equals to 0. So remember that the purpose of this problem is to find the general solution. So now it makes sense, because if you're just using a calculator, you will see you may make a mistake of just inserting one solution only and say perhaps since sine theta is equals to 0, that means theta is equals to 0. But you actually have a number of solutions. You actually have a number of solutions that can satisfy this condition, the fact that sine theta is equals to 0. So this is why you then now have to draw a diagram. You have to draw a graph of sine theta and actually see at which point of theta you get a sine theta that is equals to 0. Okay, so let's do that. Let's try and draw a sine theta graph. So we have a sine theta axis. We'll call them, let's call them f at theta, right? And then let's have a theta axis. So these are theta axes, right? Independent variable, dependent variable, right? So a graph of sine is a graph that looks like this. So this is 0, right? 0 is to 0. So it's a graph of sine is a graph that looks like this, right? So here you have your amplitude. So it's 1 here, right? And your amplitude is that you basically look at the coefficient of your sine theta. So if you have 1 here, that means from 0 going down, you must have 1 unit as well. So that means your trough is also negative 1, right? So this is why we can never have a 2 right? Can you see that there is no way of putting any theta value and getting an answer 2? So this is why this part of an equation doesn't hold, right? So if we basically label the degrees or the values of theta that satisfy this sinusoid, you have 0 here at the beginning, and then you have 90 degrees or pi over 2, but let's stick with 90 degrees since we are at grade 12. And then you have 180 here, you have 180 here, 180 degrees, and then you have 270 degrees, and then you have 360 degrees here, right? And then this continues on and on. We actually have another sine graph that the oscillations would continue propagating and continue. So you're looking at values, because you're looking at a general solution. So this is this graph here is basically f at theta equals to sine of theta, right? Okay, so this graph has a number of solutions. When you insert a value of theta from this range, 0 to 360, when you insert a value of theta on this graph, you will get any value between -1 and 1. It will depend on the value of theta. But the problem instructs us to specifically find solutions where if we put a value of theta, we get a sine theta that is 0. So where is sine theta 0? Sine theta is 0 when it cuts this theta axis, right? When it cuts this theta axis is 0. So we can see that sine theta is 0 here. So when you put a value of theta that is 0, you will definitely get an answer 0. And then it's also 0 here because we can see the graph cuts the 0 axis here. So when you put a value 180 degrees, you will get a value, sine 180 degrees will give you 0. And then also you can see that the graph cuts the theta axis there. So that means when we put the answer, when you put theta is equals to 360 there, we will have sine of 360 equaling 0. So you can actually continue this oscillation and it will go on and on and on. So that means you must find a summary of an answer that will generalize all the possible solutions that you will get as you move on with your sinusoid, with your sine oscillations, right? So we can see that the theta values, so we have to say theta is equals to, so we're writing our solution now. So we have to look at this. So when we are here at 0, we have a solution. When we are here at 0, we have a solution. So our solution, we have sine 0 giving us 0, which is true here. Then when we are at 180 degrees, we have a solution also because we sine 180 degrees equaling 0. And the same when we are at 360. So that means every 180 degrees we have a solution, right? Every 180 degrees we have a solution. So that means even after 360 degrees, if you add another 180 degrees on top of 360, then this graph will cut the theta axis, and then the sine will be 0 there. And then you go on adding 180 degrees there. So that means if we can write theta is equals to 180 degrees. So theta is multiples of 180 degrees, but you have to multiply it by some constant k times some constant k. So this is where the magic will rely. So you have to sort of say something about the k value so that it satisfies this condition that at 0, 180, 360, you have you have your solution. So we can see that if k is 0, for example, if k is 0, we put as 180 degrees times 0, we are here at 0, so we have sine 0. And if k is 1, we'll have sine 180. If k is 2, you'll have sine 360. If k is 3, we'll have 360 plus. So we can just say theta is equal to 180 degrees times k. If k, where k is an element, of 0, 1, 2, 3, up to infinity, basically. So this is now a general solution. Okay, this is now a general solution because as so long as you are starting at 0 and basically going 0, 1, 2, 3 in terms of the value of k, you will find the solution. Because when we have 0, we have a sine 0. When it's 1, we have a sine 180. When we have 2, we have a sine 360. And all of those gives us a solution that says sine of theta is equal to 0. So this is what we are looking for. This is the general solution, including that condition there. Okay, guys, so that was our problem for today. So please subscribe and hit the notification bell and leave comments and add your likes. Thank you so much. Bye.